Greetings, Kerbonauts! This is Kerbal Space Program. I'm Bob Fitch, and this is episode number 4 of Project Ares, our real solar system look at an alternate Earth. At the end of the last episode, I was showing the initial launch, the test launch. There's no payload in it. The test launch of a new vehicle. We're not actually going to send that one up next. That's just the vehicle we're working on for the one after the next launch. This launch is incorporating some new technologies like large side solid rocket motors that previously we didn't have, and some new engines for the first stage. Once we get to using this vehicle after it's fully tested, you're going to see that this one is using kerosene instead of ethanol 90. Kerosene and liquid oxygen is a fairly common fuel, and so you'll probably be seeing a lot of future rockets after that point using that sort of fuel. It's a good thing that this is a test launch because, yeah, they still have some kinks to work out of the system on the decoupling of those side motors. However, it looks like it's actually still continuing, so because it's just a test, I'm going to go as far and fast as I can and see if anything else breaks along the way. It looks like our fuel's about to run out, so we'll be testing the decoupling of our fairing, and then the extraction of the upper stage, which is actually hiding down inside that tapered interstage that's right at the top. There's no payload. That payload there is a debug computer so that I have local control, and then a big lead weight just to add mass so that I can see how it flies. Now when we decouple that upper stage, what happens is there's two little teeny gimbal engines on the bottom, and those light up, providing enough thrust to push the thing forward, bringing it out of that tapered interstage and separating it from the rest of the rocket, before then igniting the large main engine that does most of the thrust. Everything's looking pretty good, so that's about it for the test of this new tech. It's time to go back to the VAB, work on the decoupling of those side boosters, and then get ready to launch our real third rocket, which is going to be an Earth-observing satellite. Now, the fact that the technology is continuing to advance probably means that I need to explain kind of how that advancement is taking place. So here we go. This is going to come as no surprise to those of you who know me the best by now, but when I'm trying to figure out stuff like how to balance a game, spreadsheets are involved, and in this case you can see that the technology is being managed or tracked, if you will, by having lists of things that I'm going to upgrade over time. For example, you can see my first satellite, which looks like that was spelled incorrectly. My first satellite was the Omni Antenna Test, and on that satellite all I had was a battery, an open cycle engine, some ethanol 90, a low gain antenna. Well, in each of these categories, I've added some things that I think I would like to increase over time. So the next step up after battery is to start employing some static solar arrays, and then after that some deployed arrays, and then tracking arrays, and then space radiators in order to cool down everything once it all starts getting really big and hot. In the science category, we have magnetometer and the ion particles, and now we're going up to imager. Over in engines, it's going to go from open cycle to gas generator to stage, nuclear, electrical, and so on. Propellant will increase. Control over the actual launch will increase. Communications will increase over time. And what I'm doing for each launch is I'm choosing 3 things from whatever I had before that I didn't have, 3 things that I didn't have, and adding them on. So in my second launch, I chose that I wanted to go up to static solar arrays and add 2 new science instruments. And then in my third launch, I'm adding the imager, but also going over and adding gyroscopes and a short-range high-gain antenna. My fourth launch, I'll pick 3 more things from this list and increase those, and we'll just keep going like that and continue exploring out into the universe. deeper and deeper, going to the moon and Mars and Venus and exploring even the sun perhaps, landing on different planets, and then beginning to do some of the really big constructions that I'm known for, but it takes a few episodes before we get that infrastructure that's necessary in order to start doing some of those really large things in a series like this. Quickly tabbing through some of these other things, you can see that I have little spreadsheets here and there for different things I want to track. The engines being the most complicated looking one, because this is where I make sure that all of the stats for the engines are correct by measuring the exit nozzle diameters and then taking the stats from that program that I showed last time called Rocket Propulsion Analysis, bringing the stats from that over into here, plugging it in at different locations, and then getting the values I want out. So you can see this is how I was able to generate what the thrust and mass should be of my first rockets, for example. So the thrust was a formula, it was being calculated. The blue fields represent things that I have to type in, and I get that data either by measuring it, like in this case I measured in the game, I put a ruler up against the engine and I measured that it was about 0.938 meters in diameter. The ISP I got out of RPA, Rocket Propulsion Analysis. RPA gave me that. RPA gave me the mass flux, the kilograms per meter squared per second that the engine puts out, and then I have the area ratio of the throat to the nozzle, and then all of that helps me figure out that the thrust is supposed to be 510. And then as I've continued to add new engines, I just copy and paste and I fill in the stats, and I compare them sometimes to real-world engines. Like this is the one that's on the Ariane 5. This is the real-world engine. So anyway, that covers that. Over time, I will keep telling you what I'm adding each time I go up in another rocket. So the next one we're going to be making here, ooh, look at that, sneak peek. Satellite 4, our first Moon, Mars, Venus flyby type rocket. And it will be capable, therefore, of escaping Earth's gravity. The things that we will be adding are deployable solar panels, gas generator engines, and RP1, otherwise known as kerosene. So you can see this was the one that we were just testing a moment ago. Speaking of testing, I think I have a little bit more testing to do, so let's get back to the game. And of course the launch that we were working on, as I just mentioned, was the third one in the series of using our initial launcher here. We're putting up that one satellite that advances our technology in these three ways. We have the new science instrument, the Imager, which will go into a polar orbit here and will just map the entire surface of the planet, giving our humans the very first really awesome map of the planet and starting to watch for weather patterns and all that good stuff that they're interested in. As Kerbals, we're somewhat interested in the weather patterns of Earth as well, but we're more interested in things in space because that's where we're going to go exploring. We'll make various launchers over time. I mentioned there will be 3 launches using this first one, and then we'll move on to a new launcher and we'll create something there. We'll use that 3 times and we'll keep going on. The number 3 you're going to see is like this magic number where everything's going to come in threes. We'll add 3 new instruments each time and so on, or 3 new upgrades. The second upgrade, we have the Imager. The second one is our very first high gain antenna, which we'll use to direct a beam from our up higher orbit there back toward either Mogadishu or Hobyo, maybe off into India. And as it turns out, I think we're going to need another new launch site because this is a polar launch. No, I said launch site, I mean communications ground site, one of the blue dots. This is a polar launch, and therefore we need something in Madagascar down here that will allow us to maintain control in the same way that we needed to maintain control as we were launching and going over India, but now we'll go south. Now the reason, of course, we're not going to go north is that's going to fly right over land. Going south, we go over water, so if anything happened, it would splash down in the water. And with a remote tech link in Antananarivo, hopefully I said that correctly, we'll be able to maintain communication as it flies overhead. Oh, and as I look at it flying here, I'm reminded that I'm using a new fairing too that doesn't quite count in that whole new technology thing. The idea of fairings isn't new to them. I had a fairing on my last 2 launches. This is just a slightly different color and shape of fairing. So the fairing's not new, it is the control moment gyroscopes, or reaction wheels, if you will, that are the new technology. We'll slowly improve that tech as well, allowing larger and larger versions that use less power and have more available torque. Okay, so one of the double-edged aspects of real solar system is the long launches. If I cut them down to Kerbin scale times, then it doesn't do my world justice. If I let them be full length, then they can get boring. So I'll do my best to find a happy middle ground for launch durations. But one of the nice silver linings is longer launches also gives me more time to discuss parts of the world or historical missions that never happened, and therefore you won't get to see them in Project Alexandria, but you may get to see them here, and things like that. And one such example for my New World info is the formation of the New World government in Rotterdam and the meeting that led to it. During the real World War II in 1940, there was an attack on the Netherlands to force their surrender and capture the country. The Germans pioneered an attack method that today we call a Blitzkrieg. Simply put, it's an attack method that punches through the front line of a defender, drives deep into enemy territory, and takes over key strategic locations that disrupts the enemy's ability to respond to the attack or even properly set up defenses. You capture or destroy supply lines, then encircle and conquer heavily defended locations later. As part of the attack on the Netherlands, Rotterdam was struck very hard by a German blitz. Aerial bombardment destroyed a huge area of the city, killed about 900 people, displaced 85,000 others. And on my alternate Earth, this attack still did take place, and Rotterdam was leveled. As part of the reconstruction effort after the war, and as a symbol of rebirth, Rotterdam was selected as the seat of the New World government for our alternate world. The selection was made at a conference in the Netherlands as well, but I'll give you more details about that in a future episode. Right now, I'm checking the payload antenna and making sure that it's pointed at the right target because we're about to temporarily go out of communication. We'll pick up communication from Madagascar in just a moment, a little bit further over the horizon during the launch. Since this is the new high-gain antenna, it's a dish, it has to point toward its target rather than being omnidirectional. Okay, let's re-look at my checklist for this series and cross off things we've newly covered. We already did 13 and 14 last episode. Number 8, technology advancement rules, we sort of covered by now as well. I told you that I will be improving 3 things per mission and slowly extending our capabilities. We'll get into Kerbal launches as soon as possible, but for now, we still need to build up a few more unmanned technologies. For number 7, Rotterdam, I explained how the reconstruction effort after World War II was one reason it's the seat of the New World government. Along with being centrally located to the world powers and therefore easy for everyone to reach, and very near the sea. The sea is important. Did you know that 90% of worldwide non-bulk cargo today is transported by cargo ships? So it's really important to have a port. And did you know that it was a man named Benjamin Fitch who pioneered standardized reusable shipping containers in the United States? Although all over the world standardized shipping is starting to take hold, and in the next few years one size will become the standard across the world. At this point in our alternate Earth history, the shipping industry is going into an even bigger boom than it did in real life. The introduction of Kerbal technologies has accelerated every industry, everywhere, not just space technologies. Ships, trains, air, trucks. The world transportation budget will rise from 5% of the world GNP to 25% in the next few years, which is essentially the same thing that happened in real life after the war as well, though it took a bit longer. Oh, and one more thing before we close this chalkboard. Number 6, the Earth Union Space Agency history and location. Last episode I promised to say why it's in San Francisco. Well, first, a little history. In real life, NASA was formed in the United States as a result of the Sputnik launch. Since that didn't happen in my world, NASA doesn't happen either, so it's not going to be in Houston. But where? Well, South San Francisco is known by the nickname Silicon Valley, the heart of the high-tech industry. Although it didn't get that nickname until the 1970s, it was already becoming a hotbed of technology as early as the 1930s. So the first reason is that San Francisco is the perfect place for Kerbal technology to be developed. But there's a second reason. Many military personnel were of course let in on the secret of where the Kerbal tech is coming from. Most of them were stationed in San Francisco, so it made sense to station the EUSA there as well for that second reason. Oh, and by the way, after World War II, one of the military men let in on all of this was a Captain Eugene Wesley Roddenberry of the United States Army Air Forces, also stationed in San Francisco at the time. He was captivated by the almost magical technology of the Kerbals and requested to be the military liaison for the USA. His request was granted. The buildings and interior spaces were designed by a man named Matt Jeffries, and let's see, notable founding members of the USA are of course Wernher von Braun, Sergei Korolev, but also scientists Freeman John Dyson, Ralph Asher Alpher, Georgy Antonovich Gamov, and Jean Hendrik Oort, many others that perhaps I'll talk about in future episodes. Alright, our payload is up there. We're in a polar orbit going over every part of the planet. We'll open up the shutter on our camera here, allowing us to take various pictures at intervals. It's automatically programmed by the scientists to take pictures every so often and then transmit them back anytime it's passing over one of our ground stations. We're going to need to get a whole lot more ground stations though in order to be doing this sort of communication as we add more satellites. This one should stay up there for several months before the orbit decays and it re-enters. The booster will also come back in probably quicker than the satellite. There's more surface area on the booster that we had just decoupled there a little bit ago. So it'll create more drag and it'll drop back down quicker. One of our new technologies we're using on this is the stabilizing gyroscopes. That'll allow us to maintain our orientation so that we can take pictures of the Earth. We need a special kind of camera to be able to take those pictures because we're moving so fast over the ground. To keep them from being blurry, we need a special camera. But like all the other things, that's some new technology that the Kerbals have been able to introduce to the humans a little quicker than it would have been had Earth done it on its own.
Still no contact. And no idea why they had to shut it down? Nothing. All they said was there was an energy drain that was getting worse, and it was better to be safe by shutting down the link until they knew more.
Maybe there's something we can do on this end to diagnose the problem?
I think that's why Bob called this meeting.
Where is he?
He was talking to the humans, explaining the situation. He should be here in a minute. Alright everyone, listen up. I just talked to the humans. They say they understand the situation we're in. They've agreed to add more scientists to the Anomaly Research Division to help us get the wormhole opened again and to restore communications back home. The bickering between von Braun and Korolev is getting worse though, so that's not helping. There are also some questions about von Braun's ties to his old country, and some humans think he should not be a member of the team anymore. Also, Jean, our United States liaison, says the peace between districts is breaking down. Many humans are starting to question why a world government was needed at all. And Jean thinks we may need to reveal ourselves soon, or there could be military conflicts between districts again. For now, we need to continue with our other tech advancements as well, so let's see that latest mission schematic one more time. There's one more test to run on the side solid boosters for thrust levels and decoupler strength, and the engine just finished its final tests, passing them all. The upper stage needs a fuel quality check, and one last thrust level check there, as well as a payload test, and we can check
That's just about it for episode number 4, Kerbinauts. I'm here on the pad, checking the thrust levels, checking the visual effects, making sure that the booster flame looks pretty, making sure that the thrust levels go from 0 up to the proper percentage in the right amount of time, and then they're supposed to drop down over time. You can see in my UI there, it shows the thrust level as a percentage. I'll get that all figured out and we can see it next time. Until then, I will see you later, Kerbinauts. Antananarivo. Maybe that's it. I'm with the remote tech link in Antananarivo.